Hi, in this video we have the note packet notes for section 8.4, rectangles, rhombuses, and squares. Alright, in this upper right hand corner, go ahead and fill out the date that you're filling in these notes so you have that as a reference. And we'll start with a rectangle. So a rectangle is a parallelogram with 4 right angles. All right, notice our right angles are highlighted over there. Okay. Moving on to a rhombus. A rhombus is a parallelogram with 4 congruent sides. Again, that symbol for congruent, sides is right there. And again, that's marked over here on my picture with my 4 tick marks that show me that they're all equal to each other. The last definition that we have today is a rectangle or a square. And a square is a parallelogram with 4 right angles and 4 congruent sides. And a square can both be a rectangle and a rhombus. Not sure why that's not writing very well. I'll fix that for you. This rectangle and a rhombus. Okay. Moving down here, we have a little flow chart that kind of ties everything together. Remember, you can pause at any time if you need to catch up with where I'm at. A quadrilateral is a parallelogram. We know that because a quadrilateral is a figure with 4 sides and 4 vertices. A parallelogram we learned about in the last section has opposite sides that are congruent, both pairs of opposite sides that are congruent. And a parallelogram can be a rectangle. Oh, it doesn't look like a C, sorry. Fix that. And a rhombus. Both fit the definition of what a parallelogram needs to have. And then the other part of this flow chart leads me down to a square, because a square can be a rectangle and a rhombus. Another way to look at it is right over here in your Venn diagram. Pretty sure we should all be familiar with those. So squares right here in the middle kind of share both features of rhombi and rectangles. And rhombi and rectangles both fall in that parallelogram circle. And all of those fall into that quadrilateral because we have a quadrilateral has 4 congruent sides. Or it contains 4 sides and 4 vertices. Sorry about that. Okay. Let's move on to the next slide here. Make this a little bigger. Move it down a little bit. Now we're going to talk about the properties of diagonals with our rectangles, rhombuses, and squares. The first one we're going to look at is our diagonals of a rectangle. So we're first looking at a rectangle here. In a rectangle, the diagonals are congruent. Okay, so if I look at both of these diagonals from the opposite sets of vertices, those are the same length. All right, and the diagonals of a rhombus are perpendicular. I'll write that down here too. And notice in the diagram here we have that marked with our right angle. So we would have 4 right angles there with the diagonals of a rhombus. And then this last one, the diagonals of a rhombus, are also angle bisectors. So they cut my angles at each of the vertices into two congruent angles. So one would be congruent to 2. Angle 1 is congruent to angle 2. Angle 5 is congruent to angle 6. And I'll add the other ones in there just so you have them. Angle 3 is congruent to angle 4. And angle 7 is congruent to angle 8. And highlight that. So again, those diagonals of the rhombus also bisect the angles of the vertices. All right, moving down here, example, we're going to find we're going to find xz in a square if x, y, z, w, so that's naming my square, if I know that wy, let's highlight that, so wy right here is 14. Draw a little arrow and mark that as 14. So what do we know about our diagonals? Let me highlight what we're looking for. We're looking for xz here. Okay. So if I'm looking at xz, what do we know about diagonals of a square? Well, we're going to refer back to what we know about diagonals of a rhombus, because remember, a square is also a rhombus. And the diagonals of a rhombus are perpendicular to each other, and the diagonals of a rectangle are congruent. So we're going to use what we know about both of those, since a square is a rectangle and a rhombus. Therefore, we know that xz is equal to 14 as well, because they're both a diagonal. And remember, a square is a rectangle and a rhombus. So we're going to use that, what we know. All right, and the last one here, we're going to find the measure of, let me highlight it. I'll highlight it in gray for you. Y, O, X. And we are going to use what we know again about the diagonals of a square, which in turn is diagonals of a rhombus and a rectangle. And what we know about that is that the diagonals are perpendicular to each other, and that's because of the fact that the square is also a rhombus. So we know that the measure of angle YOX is equal to 90 degrees because of that rule of our diagonals. Remember, a square is both a rectangle and a rhombus, so that's why we don't talk about diagonals of a square. We talk about diagonals of a rectangle and a rhombus. And we use that to help us show that those diagonals are congruent to each other, and that those diagonals are perpendicular to each other, and in turn makes that, that 90-degree angle right there. All right. Down below here, you do have your homework listed. Remember, it's the next page of the packet. Assignment number 4 here. You got 16 through 21 all, 22 through 38 even, and then 39 through 44 all.